right, in this video, I'm going to show you how to use the tape diagram as a way to help students visualize what percent increase and percent decrease, and really any percent problem, help students visualize what that looks like. Because once students can visualize the problem and can represent that problem in a tape diagram, suddenly the math itself becomes really easy, and it becomes something that students can do because they understand it, rather than they're getting the answer simply because they're following some sort of rule or algorithm or mnemonic that the teacher has given. So let's get started. We got a problem here. It says your standing heart rate is 90 beats per minute. Lying down, your heart rate is 72 beats per minute compared to standing. What is the percent decrease in the heart rate? Okay, so what we're going to want to do is we're going to teach students how to represent this problem visually. So we're going to use a tape diagram, and that tape, we're going to begin with a tape, and that tape always represents 100%. So here is our starting place. And we're going to go back and we're going to read this problem again. And it says your standing heart rate is 90 beats per minute. It then changes to 72. So we're going to learn that the original amount, whatever that original amount is, I don't know if I could come up with any exceptions, but whatever that original amount is, that is what represents the 100%. All right? So the original represents the 100%. So this 90 beats per minute is the original beats per minute in this story. Not necessarily because it came first in the story, it just happens to be the starting position. If your standing heart rate is 90 beats per minute, lying down is 72, compared to standing, what is the percent decrease in the heart rate? So that's basically meaning this 90, this original 90 beats per minute is your original, which is 100%. Now it says it goes down to 72%. It decreases down to 72. Now I don't know where 72 is, but it decreases, and I'll stop right here at 72. So what does that mean? That means this portion here is the 72, and this portion here is the decrease. So I'll use green, and I'll say, okay, this piece right here is the 72, because that's the lying, what is it, lying down? Yeah. So that's the lying down rate. And then I'm going to use red to say that this here is the decrease. That's the decrease. So if this original, the original whole thing was 90, we went down to 72. That's this piece right here. This amount right here is 18. And that's because 90 minus 72 equals 18, all right? But that's not the answer, because what we've got is 90 beats represents 100%. 72 represents an unknown percent. We don't know what percent 72 beats is, so I'm going to put a question mark there. And we also don't know what the 18 represents as a percent. So we've got these two unknowns, and technically we could get either answer, and either answer will lead us to the correct answer. But at this point, the most efficient way to do it is to really think about this, because it's asking what is the percent decrease, which means, well, we know the actual decrease was 18. So we need to convert that 18 into a percent. So let's do that. So what we're going to do is over here on the side is we're going to think about a table of equivalent ratios. And there's a lot of ways to do this, beats per minute. So we know that 100% represents 90 beats per minute. How do we know that? It says right here, 100% represents the 90 beats per minute. And so now we want to know what percent represents the 18 beats per minute. And so that's going to be all the way down here. 18 beats per minute represents what percent? And we can have any number of equivalent ratios in between there, couldn't we? And so now what we're going to do is we're just going to think of a series of equivalent ratios. Basically, we've done the work. The hardest part of the work is to visualize the story. What is the story? 90 was the whole. It decreased to 72, which means it decreased by 18. Now we have to convert this into a percent. We know that 90 out of 100, 90 beats represents the 100%. And now we just do whatever math we want to do in terms of equivalent ratios to get that 90 beats to become 18 beats. So one idea, well, we could divide by 10. And when we divide by 10, we could divide 90 by 10 to get 9. Which means we're going to divide 100 by 10 to get 10. Well, now it's a walk in the park. Once we have 9 beats, all we have to do is double it to get 18, huh? So I'm going to double it to get 18, which means I'm going to double the 10 to get 20. And so now we know that our percent is 20%. So 20% represents the 18 beats per minute. So what's the percent decrease? The percent decrease is a 20% decrease. Okay? So that's it. I'm going to do one more problem just as an example. It's not terribly hard. So let's scroll down. All right, we have during the month of July. There we are. During the month of July, Fabulous Feet Shoe Mart sold 50 pairs of red loafers after an ad campaign. They increased 40% in August. How many pairs were sold in August? All right, so all we have to do is, again, we're going to start by drawing that tape diagram. And of course, that tape begins by representing 100%. All right, we're always going to start that. This is generally always going to be your starting position. It says, during the month of July, Fabulous Feet sold 50 pairs of red loafers. That's the original amount, remember? So we're going to call that the 100%. So in this case, our 100% is 50 loafers. But it says after an ad campaign, it increased by 40%. There we go. So we know that 100% is represented by 50 loafers. 40%, we don't know how many loafers that is. In fact, we're being asked how many pairs were sold in August. So really, technically what we're looking for is how many loafers were sold in August, which is this entire amount. This is August. Because remember, July was just the 50 loafers, but August got bigger by 40%. So really, August is this entire thing. So what's our percent table? What's our proportional table going to look like over here on the side? Percent, and I'll put number of loafers. So what's a ratio that could go into our table here? Well, here, right here. One ratio is 100% is 50 loafers. 100% is 50 loafers. If we want to know all, oopsies, did the wrong color. If we want to know all of August, that's going to be 140%. 100 plus 40. So here's our table of equivalent ratios. And really, we want to know how many loafers is represented by 140%, because that's the entire amount. So there's a lot of math that we can do, but I'm going to do the easiest one. It's, super duper easy. I'm going to first divide by this equivalent ratio, both of them by 100. I'm going to divide both 100 by 100 and 50 by 100. So 100 divided by 100 is, of course, our unit rate, which is 1. And 50 divided by 100, I'm just going to leave as 50 over 100, also known as 1/2, if I want to change it to a fraction. Because the reason I did that is because now it really becomes easy to turn a 1 into 140. All I have to do is multiply by 140. Multiply by 140, which means what am I going to do with this half? I'm going to also multiply it by 140. And 140 times 1/2 gives me 70. So I now know that August, all of August, is 70 loafers. I guess pairs of loafers. There we go. Now, if we really zoom in on this table, we could have seen a shortcut. We could have seen that 50 times 2 is 100. So all we needed to do is say what times 2 gives us 140. And so that makes this finding the answer of 70 super easy. It would have been a lot easier just to do that, is to think about that horizontal relationship rather than the vertical relationship. And that wraps up the idea of using tape diagrams to get percent increase and decrease problems. Really, the key point is using those tape diagrams to create the visual representation to help students understand the math that they then need to do to get the answer. It's not about the answer. It's about making sure we represent the problem visually in a way that helps our students understand what's going on, which makes the math super easy.